Welcome, folks. We're going to take a look at how some Venn diagram problems work, okay? This is a pretty big document, lots and lots of problems. We're just going to take a look at a few of them together here. If you want to print this out and have it as we go through, that's not a bad idea. And if you want to practice some of the other problems, you can do so. There's some answers at the very end of the document. It's a pretty big document, but we're just going to do a few together here to get a sense of how these things work, okay? So let's take a look at this first example. Numbers are written on cards. The cards are shuffled and one is selected at random. The outcomes for this experiment in events A and B are shown in the Venn diagram. Complete the following. All right, and the questions are basically having us fill in, what are the elements in these different sets, okay? So as we look at the entire sample space here, we basically have the numbers 0 through 9, okay? 0, 1, 3, 5. In the A circle, we have 2, 4, 6, 8. In the B circle, 6, 8, 7, 9. And 6 and 8 are right in the middle there, okay? Part A, the sample space S is, well, this just refers to everything within that rectangle. So that's every number we see, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so for part A, now there's not really a lot of room to write up in this region. I can't write all those numbers there. So what I'll do is I'll just kind of put the parts down here. So for part A, S is all the numbers in the set. Okay, so that would be part A. And up here, I guess I'll just write 0 through 9. Okay? All right. Okay, part B. Event A, what are the outcomes in event A? Well, that's anything that's in that circle. So that's going to be the 2, 4, 6, and 8. And I can just fit that in there, so that's pretty good. Okay, now part C, event not A, refers to everything that's not in circle A. Okay, so if all this stuff is in circle A, I'm looking for everything else. 0, 1, 3, 5, 7, and 9. And we can write not A like that. Okay, and that's what we mean by not A. All right. Moving on to part D now. Event B, anything inside of circle B. So there's circle B, and we're looking at 6, 7, 8, and 9. Event not B is everything else. Not B would be 0, 1, 3, 5, as well as the 2 and the 4 that are in A but not B. All right. Part F, event A and B, that's what's common to both sets. That's our intersection here. And the intersection just includes the numbers 6 and 8. So there's the and. Those are the number of elements in the and, the intersection. Okay, for part G, event A or B or both. That's going to be anything in A, anything in B, anything in both. So anything within these two circles. Okay, so that's going to be 2, 4, 6, 8, 7, and 9. Okay, is this an inclusive OR event or an exclusive? Well, in this case, we're including the both. This is what we would call an inclusive OR, when we include the both. Okay, as we look at the next part, event A, this is part H, event A or B, but not both. So anything that's in A or B, but not in both of them. So here we're excluding the intersection. Okay, so we're looking at 2, 4, 7, and 9. And this would be an exclusive OR event because we're not including the both. Okay. And finally, what's left? Part I, event neither A nor B. What's the stuff that's not in either? So that would be the 0, 1, 3, and the 5. Okay, so there's using a Venn diagram and just kind of, if we're asked for these different regions or these different sample spaces, we're just showing that we know what we're talking about here, okay, what goes in what region. All right, let's take a look at the next example where we'll actually fill in with the numbers this time. In a class of 30 students, 5 study Japanese, 13 study French, 9 study German. 2 study both Japanese and French, and 5 study both French and German. Complete the Venn diagram where J is the event studies Japanese, F studies French, G studies German. Okay, so they give us all the numbers on the side. We got to put them in here. Okay, now we know in total there's a class of 30. Okay, 5 study Japanese. Here's where we need to be careful of. We're not necessarily going to put this 5 here. Okay, it says 5 students study Japanese. That would be 5 students who study Japanese only, but not French. Okay. There are some students here who study both Japanese and French. Okay. That's the intersection. So really what's going on here is this, right? There's 2 students that are going to study both Japanese and French. Now, in total, there are 5 who study Japanese, right? Within this entire circle for Japanese, that's going to add up to a total of 5 values, okay? So how many values have we accounted for? 2. So how many students does that leave to study only Japanese and not French? The remaining 3, okay? So this is where we got to be careful putting numbers into Venn diagrams. Okay, the idea is always start with the intersections and then work your way to the only regions. So here, 2 students study both Japanese and French. I'm going to put a 2 in there. 5 study both French and German. So I'm going to put a 5 in that intersection. Now I'm going to go to the onlys. 5 study Japanese total. So within the Japanese circle, it would add up to 5. We already have 2, which leaves us with 3 that study only Japanese. So we've got our 5 total, 2 of which study both languages. Let's look at the next. 13 students study French. Okay, so this is going to add up to 13. We already have 2 on one side and 5 on the other. We've already accounted for 7 students who study French. What's 13 minus 7 leave us with? 6 who study French only. Okay, now within the French circle, that adds up to 13. Last but not least, we have 9 students who study German. We've already accounted for 5 of them, which means there are 4 left to get to 9. Okay, so in this case, there are 4 that would study German only. All right, so work from the intersections and then work your way out, often just using some subtraction to figure out what's left over. Okay, and if I want to be careful here. Again, we know we have how many students total? 30. What do we got here? If I add 3 plus 2, plus 6 plus 5 plus 4, that only adds up to 20. So what does that mean? Well, there's still 10 students unaccounted for out of the 30. That means that there are 10 students in this class of 30 that don't end up studying any languages here. Okay, now we've completely accounted for our sample of 30. All right, let's go through the questions now. Part B. How many students in this class do not study a language? Okay, that's the first thing they asked. Well, we figured that out. That was the 10. How many part 2, over to the right there. How many do not study Japanese? So let's account for all those that do not study Japanese. We would add those numbers together there. 6, 5, 4, and 10. And that's going to add up to 25. So there's 25 students that do not, which makes sense, right? If there's 5 that do out of the 30, the other 25 don't. Okay. Part 3. How many do not study French? Okay, so I'm going to add up the numbers not in the French circle, and that adds up to 17. How many do not study German? Okay, I'm going to add up all those that don't study German, and that's going to be 21. How many study Japanese or French or both? Japanese or French or both. Okay, we're going to include that 5 too, because that's somebody who studies French. So adding that up, we get 16. How many study Japanese or French but not both? Japanese or French but not both. So we're going to get rid of the 2 there, and that's going to add up to 14. Okay, study French or German or both. French or German or both. Okay, and that adds up to 17. How many study French or German but not both? So let's just get rid of that 5. We have 8 French and 4 German is 12 that study one or the other but not both. How many study Japanese or German? Okay, there's 5 that study Japanese, another 9 that study German, so that's going to be 14. How many study Japanese and French and German? There are no students that do all 3, so that's 0. All 3 circles do not intersect. How many study Japanese only? Okay, that's the 3. French only, 6. German only, 4. How many students study exactly one language? Well, there are 3 who study only Japanese, plus the 6 who only study French, and the 4 who only study German, for 13 students who only study one language. How many students study exactly 2 languages? Well, there's 2 who study Japanese and French, and another 5 who study French and German. So there's 7 students that study exactly 2 languages. How many study at least one language? At least means 1 or more. Okay, so 1 language was 13, 2 languages was 7. Nobody studies 3, so that's it. There's a total of 20 students who study at least 1 language. Okay, and in fact, that's just what this all adds up to. All right, and the final one here, study at most. How many students study at most 1 language? That would be 1 language or no languages. Okay, so there were 13 that studied 1 language plus 10 who study none, for a total of 23. Okay, so again, pause as you need to, try to make sense of these. And again, the big thing is being able to label given the numbers up above. Okay, let's try one more example. We're going to go down to number 4 here. Okay, in a class of 30, 25 passed the term mathematics test, 24 passed the science test, and 23 students passed both. Draw a Venn diagram to represent this information, using M for the event passed the math test and S for passed the science test. All right, so we'll have a rectangle for our entire sample space, and we will have 2 circles that intersect. Those who pass the math test, those who pass the science test. Okay, now again, what we're going to do is we're going to start with the intersection. Okay, there were 23 students who passed both tests, so I'm going to put that number in there. Now, it says 25 passed the math test, so in total, there are going to be 25 within the math circle. We've already accounted for 23 of them. 25 minus 23 leaves us with 2 students who passed the math test, but not the science test. 24 students passed the science test. We've already accounted for 23 of them, which leaves 1 out of the 24 who only passed science and not math. Now, if you look at the numbers we have, add those 3 up, we've got 26 students accounted for. There were 30 students in the class, so what does that leave us with? 4 students who passed neither exams. Okay? Now let's take a look at part B. How many students from the class did not pass the math test? Okay, well, it looks like 1 in 4 leaves us with 5. And again, that makes sense. If 25 did pass, the remaining 5 did not. How many students passed neither math nor science? That's the 4 that did not pass either. How many passed math or science, but not both? I'm just going down the left-hand side here, and then we'll take a look at the ones on the right. How many passed math or science, but not both? Well, 2 passed math, 1 passed science, so that's 3 that passed one or the other, but not both. How many passed science, but not math? There was 1 student who passed science, but not math. How many passed at most one subject or fewer? That's going to be 2 for math only, 1 for science only, plus the 4 who passed none. So that's 7. How many failed at most one subject? They failed one subject or they failed no subjects. Okay. Those who failed one subject were these 3, and those who failed no subjects were those 23. So those who failed at most one subject, 26. Okay. Now let's take a look at the right-hand side. How many did not pass science? There's 2 here and 4 there for a total of 6. How many passed math or science or both? That's all this stuff, which is 26. Okay, that's basically the same as failed at most one subject, but it makes a little more sense in the way they asked it here. Okay, next one. How many passed math but not science? How many passed math but not science? Oops, I just erased it. 2. 2 students passed math but not science. How many passed at least one subject? Okay, one subject or more. That's again 26. Okay, how many failed at least one subject? Did they fail one or did they fail all? That's going to be the 7. Okay, failed at least one. That would be the 2 in math, the 1 in science. And failed more than one would be the 4 left over. Okay, so again, these are basically the same question, just asked in different ways. Okay, so again, you can scroll through this. There's a lot of practice problems. If you want to take an opportunity to practice them, go for it. And at the very, very end of this thing, there's some answers for you. Okay, if you have any questions, let me know. Thanks, folks.